The last algorithm we're going to discuss in this lecture is a super cool sorting algorithm called Mergesort. It's kind of amazing when you think what it's actually doing, and we'll get there. And what's actually fun about this algorithm is not only is it really clever, but the analysis of its runtime is really interesting and fun. It has a nice flavor to it. Now, before we get there, we're going to have to handle a few less interesting issues. First, I need to tell you what selection sort is. We're going to talk about arbitrary units of time, and we're going to talk about merging. Okay? But once we have all the pieces in this video, we'll be able to do the really cool analysis in the next. So let's start with selection sort. This is actually an algorithm we've already seen in this class, but as a reminder, how it works is I have an array, say 6, 3, 7, 2, 8, 1. Okay? I look through that entire array and I find the smallest item, in this case, 1. I take that 1, I move it to the front, and then I selection sort the rest. So I look through all of this, find that 2 is the smallest, copy the 2 to the front, and so forth. So this algorithm, selection sort, we can also do an analysis to see what its runtime is. And I hope that it's pretty quickly clear that it's n squared. And one way to look at that is it's just the area of a triangle. Or if I alternately want to do an exact count, I could say, okay, well, let's count the number of things that are looked at. So I use looking at as my cost model. And I say, well, there's n items to look at the first time, then n minus 1, and so forth until there are only 2. And so the overall runtime, where our cost model is looking at, would be 2 plus 3 plus 4 plus 5 plus ... plus n is big theta n squared. Okay. So that's our basic analysis of selection sort. We got that out of the way. Great. Okay. Now here's where I'm going to talk about things in a new, slightly different way. I'm going to introduce, for the sake of really being able to emotionally and intuitively understand Mergesort, I'm going to talk about something known as arbitrary units of time. So this is not a really well-defined mathematical notion, but I find that this is a really useful idea to feel this on a deep level, what's going on. So let's say we're selection sorting 6 items. We can say that since selection sort's an n squared algorithm, it's going to take maybe 36 arbitrary units of time, roughly, hence the tilde. If I have an array of size 64, well, in that case, the total runtime is going to be 64 squared in this arbitrary units of time, which 64 squared is 2048. And so it gives me a rough estimate of how much slower an array of size 64 is going to be compared to an array of size 6. Okay? Now, it's only a rough estimate, but I still think that this notion should be really useful to us when we do the analysis in the next video. So the last thing I want to talk about in this preliminary video before we get to Mergesort is the notion of merging. And so what the merging operation does is it's a way to take 2 sorted arrays and make them into one gigantic sorted array. And the way it works is pretty simple. So given 2 sorted arrays, say 2, 3, 6, 10, 11, and 4, 5, 7, 8, the merge operation takes them and glues them, or combines them into one sorted array by simply comparing the smallest item in both arrays and copying. And then it just repeats that over and over until every item has been copied. So we compare 2 and 4, 2 is smaller, 2 gets copied. Great. Okay, 3 and 4, those get compared. 3 is smaller, so 3 gets copied. Now we compare 6 and 4. We've already got 2 and 3 out of the way, so we don't look at those anymore. So 4 and 6 are compared, and we copy the 4 because it's smaller. 5 and 6, 5 is smaller. 6 and 7, 6 is smaller. 7 and 10, 7 smaller. 8 and 10, 8 smaller. And at this point, there's nothing left to copy from the right array, so we'll simply copy the rest of our left array, 10, 11, and we end up with a merged array. Okay? So it's a way to take 2 sorted arrays and make them into one big sorted array, and it's a pretty simple process. And what we'll see in the next video is how we can optimize selection sort using this merge operation. Now, before we get there, I have one question for you, and then we'll move on to the next video, which is, what is the runtime of this merge operation in terms of n, the number of items? So for this array I'm showing here, n would be 9. So hopefully you can see that it is theta n. And the argument here is, well, let's imagine using array write operations as our cost model, writing to this output array. In this case, we're going to do exactly n writes, so the runtime is going to be clearly theta n. You could also do examinations, and it will also still be theta n, whatever you want to do. But hopefully it's clear that it's theta n, and if not, make sure that makes sense before moving on to the next video, which will be cool.